Good morning. I'm so happy to see so many of you here this early in the morning. Thanks for joining me. So, as developers, we tend to go through different stages. My first stage was when I was about 7 or 8 years old. I got my first computer, and I remember I sat down, I wrote 10, print Jimmy, 20, go to 10. So that was my code. I got my computer to do stuff for me. This is actually my first app. And if anyone wants the source code, I will be happy to share it. This is actually the moment when I realized that I wanted to be a developer. This is what I wanted to do with my life. The next stage was when I got a calculator and a mobile phone. There's a very special feeling when you're writing something on your computer and then you deploy it to something smaller that you can bring with you in your pocket. I could actually sit down and write code on my calculator during class. Mind-blowing for me. The third stage was when I was introduced to circuit boards. Raspberry Pi, Netduino, Arduino, and stuff like that. I remember I went into the living room and I yelled to my wife, Jessica, you got to come and see this. The LED is blinking. Look, the LED, it's blinking. On, off, on, see, it's blinking. And she just went into the room, yeah, what about it? No, you don't understand. The LED here on the circuit board is blinking. I made that happen. I think it was a bigger moment for me than for her, but I was so happy. The LED was blinking. Then the next stage was when I realized that I can control other devices. Devices that I actually don't have any code control over. I can get measurements from sensors. I can turn off and on lights. And this is what we're going to talk about today. Bluetooth. How we can control devices through Bluetooth. But why should we care about this? Well, first of all, it's really, really fun. And the second reason is this number. 3 billion Bluetooth devices were manufactured last year. Of course, we want to be here as app developers. Make apps for this customer base. So what we're going to talk about today is how does Bluetooth Low Energy work? How can we figure out a Bluetooth protocol? And then we're going to go from Bluetooth Low Energy all the way to IoT and see if that works. So my name is Jim Engström, and I work as an ASP.NET developer. I spend my spare time doing Windows and Windows Phone development and some HoloLens. And together with my wife, I run a user group called Coding After Work and a podcast with the same name. I'm also a Windows development MVP. But enough about me. Let's dig deeper into this fun stuff. So Bluetooth Low Energy has many names. It's called Bluetooth Smart. It's called, there we go. It's called Bluetooth LE, Bluetooth Low Energy, BLE, and sometimes, wrongly I should say, Bluetooth 4.0. It's part of the Bluetooth 4.0 standards, but it's not the whole thing. Bluetooth Low Energy was actually introduced back in 2006 by Nokia under the name Vibri or Vibri, however you want to pronounce it. And then 2010, it became part of the Bluetooth Core 4.0 standard. The nice thing about Bluetooth LE is that you can actually ask the device, what can you do? What services are you implementing? That's perfect for developers. It's easy to reverse engineer, to figure out the protocols. So a BLE device can tell you what services, what service it has. A BLE device always has one service or many. It must have one. The service is identified by a GUID. So there's an organization called Bluetooth SIG, Special Interest Group, that has named a couple of these services. They have documented them, and they have said that to be able to use this GUID, this service needs to look a particular way. There are also, of course, services that are not defined by Bluetooth SIG, and we will go into those later on. One service has one characteristic or more, must have one. You can think of them like methods or events, because every characteristic has a way to access them. You can read, you can write, you can indicate, and you can notify. And the last two of them are, you can see them as events. So those are, your device is going to send those values back. So this is the documentation from the Bluetooth SIG, the special interest group, for the battery service. So their documentation says that to implement a battery service, you need to have a characteristic called battery level. It must have read access. It wouldn't be much of a use if you couldn't read the battery level, right? And then it may have notify. Doesn't have to, but it could. So let's look at this service in another way. So we have the BLE device. It has a battery service. It has a battery level characteristic, and it must have read, and it may have notify. The really cool part of this is that you can actually build generic apps. You can say that my app wants to connect to any device that implements the battery service. So you don't have to write specific app for a specific device. So now when we know how to communicate or how they work, how do we talk to the device? Well, the first step is to pair the device. You can do that from within Windows, and you can do it programmatically. They're actually working on, now I'm talking Windows 10 specifically, they're actually working on pairless Bluetooth as well, but they're not there yet. So you just search for Bluetooth settings, you click your device, and you click pair. Sometimes you get this window. Usually it's 0000, 1, 2, 3, 4, or something like that, or you can probably find it in the documentation for the device. Or you can do as I did. I just tried 0000, 0001, 0002 until you got it. Luckily, it's what 0007, so you didn't have to do that for long. So if you want to do this programmatically, you set up a device watcher. You can request properties that you want to have access to. So in my case, I want a device address, and I want to know is it connected. Then you create a watcher. And you supply it with a filter. That's so those 3 dots. We will look at the filter on the next slide. And you supply it with the request properties. What properties do I want from it, and what kind of endpoint am I looking for? Then you just add the added and updated event handlers, and you just start a watcher. And the filter looks something like this. You can find this at MSDN or something like that. so you don't have to write it down or anything. Then we have the added event, or the event handler. In my case, I'm checking the name. I don't have to check the name, since I'm checking for services, but in some cases, they reuse the services. They reuse the GUID, so it could be a good thing to actually check the name, if it's just a particular set of device you want to use. And then, if it is the right one, you just pair it. You can also use the pairing.custom.pairasync if you want to do some special pairing code. So I found this scale on net. This is an Anderson scale, but it's actually Sensun who makes them. So I've written a small application that lists all the services, all their characteristics, all the ways that they can be accessed, because the device knows these things and are happy to share them with you. I also created a collection or a database that converts these services to their Bluetooth SIG real names, if you wish. So if we look at the Sensun scale, it contains generic access. This service will contain things like name and device address. Then we have the generic attribute. This is the service that actually makes it possible to ask the device, what can you do? Then we have device information. It contains manufacturer, versions, name of the device name, and stuff like that. And then we have another one, not defined by the Bluetooth SIG. Interesting. So the one, I know that generic access, generic attribute, and device information won't give me a weight value, because these are defined by the Bluetooth SIG. They don't have a get weight. So the one named 000FFB, I'm sorry, I'm not going to let you suffer through that. So the last one is the one I want. So looking at our mystery service, it has two characteristics. They both have a way to access them. In this case, I can write to it, and I can get a notification from both of them. So I wrote a very simple application that listened to those notifications. And from one of the services, I actually got a reply. So probably that one. So now the fun part starts, the detective work. So I get 10 bytes back. It looked like this. So I started off with a baseline, 0 grams, not putting anything on the scale. So I'm guessing that I'm actually looking for bytes that are 0. Those ones. Then I tried to put an energy drink on my scale. Just happened to be next to me. It weighed 235 grams. Now, these values changed. And I actually have 235 on byte 5. So I'm guessing that's the weight value. So now we reset the scale, remove the energy drink, and I got minus 235. Now bytes 7 and 9 changed. But byte 5 is still 235. So I'm guessing 7 or 9 is a sign byte. Then I tried with 120 grams. Suddenly, byte 4 changed. So after testing different weights, I managed to figure out that the bytes I wanted to talk to or read from was 4, 5, and 7. And the formula ended up being like this. So if I take the byte 4 times 256 plus byte 5, that's going to give me the weight. And then I can use byte 7 to figure out what sign it is. So 0 for positive, minus 1 for negative. So my first demo is going to be legend. Wait for it. Dairy. I'm sorry, I really like puns. So let's take a look at the code. So let's start with, I've actually written a couple of helper methods. So the first one is setup notify async. To get notifications, I have to tell my Bluetooth characteristic that, hey, I want notifications from you. So what I do is, the first thing is that I get the service with this particular GUID. Then I get the characteristic with a particular GUID. And then I write client characteristic configuration descriptor async, the longest method name ever. And I say that I'm interested in notifications. And this method is going to return the characteristics to me when it's done. Then I also have a read value. The same thing here. I get the service, I get the characteristic, I read the value, and I say I want it uncached, because sometimes the device will cache it for me. So that's good if you want to have low battery consumption, but in this case I want the latest value. Then if everything goes well, I get the data. I get an array, byte array. And in my case, I have made this method generic, so I can actually say that I want a string back. But the Bluetooth device is always going to return bytes to me. In this case, I just converted. I'm guessing it's UTF-8. That's not a given. And then I just return the bytes. And then we have write value. Same thing here. I get the service, get the characteristic. And here I'm actually asking, okay, what kind of way can I write to you? Can I write with the response? Sorry, without response, or can I write with the response? And depending on what it can do, I just implement that. So I just write value async. Again, bytes, always bytes. So in our application, I define the service ID. This is our mystery service. Then we have the characteristics GUID. Then I create a device selector from GUID. So this is going to give me all the devices that implements this service. I get a collection, and I just loop through them. I get the Bluetooth LE device, and, well, here I check, does the name contain Senson? Again, I don't have to do this if I know that all the devices that implement this particular service are going to use the same characteristics, but just to be safe. Then, if I get a device, I run my method setup notify async. So I say to the service, I want notifications. I get the characteristics back, and then I just listen to the value changed event. In the value changed event, I get an array back, an array of bytes. So I send it into my convert to weight method and just set the property I have on my page to the new weight. And the weight, convert to weight method is doing, well, it's going to check whether or not byte 7 is set or not. And it's going to take the sign times byte number 4, byte shifted, and then byte 5. So let's see if this works. Oh, I have an energy drink, put it on the scale, and the value changes. Pretty simple, huh? I mean, this is not a lot of lines of code to do this. So let's go back to the presentation. So Huawei is a company who makes robots, toy robots. And they've released a whole bunch of robots. This is the one to your, let's see, your left is the MIP. It's a Bluetooth robot. And the other one is the Miposaur. I actually written an SDK to talk to these two. Actually, the one for MIP is out already as open source. I'll share the link later on. And the Miposaur is coming. They also took a lot of old toys. These robots were controlled by remote control. But they have upgraded them. So now they can be controlled by Bluetooth. So let's talk a little bit about the Azure IoT Hub. Microsoft has released the Azure IoT Hub, a way to communicate with IoT devices. So what I could have done here is that I could have shown how to upload sensor data to the cloud and do stuff with it. That's no fun. I wanted to do something more fun. So we're going to try to control one of these robots through the Azure IoT Hub. So the first thing we need to do is actually set up the IoT Hub. I've done that in advance, so it's a little bit quicker to do this with slides. So the first step is to click New. So this is the Azure portal. The next step is to click Internet of Things and then Azure IoT Hub. So let's name this NDC. I have chosen to use the free price and scale tier, and I've chosen location Northern Europe. Just create, and then you wait for a couple of minutes. Then you will see this screen, and your IoT Hub is ready for use. The free tier actually gives you 8,000 messages that you can send through the IoT Hub for free. So that's awesome. The next step is to install the Device Explorer. It can be found on this URL. You can download the source for it, or you can download a full installable. It looks something like this. So to be able to use the Device Explorer, you need a connection string. So let's go back to the Azure portal. Click the key, Then IoT Hub Owner. This is created for you, so just click away. And then you have the connection string just there. Copy it and paste it into your Device Explorer. And you're all done. So now we can go to the Management tab and click Add. So we could have done this from code, but since we're just only going to use one device, this will work perfectly. So I'll name this RoboSapien, and I just press Create, and I get it nicely in my list. Then to create your application, I have chosen to create a universal Windows platform app. This will, of course, work with any app. So the first thing you need to do is to install the Microsoft Azure Device Client Nougat package. Once that's done, you can go to this URL. Microsoft actually helps us even more with this. So this is not going to be an Azure IoT Hub deep dive. I want to open your eyes to see how cool and how easy it is to communicate through the IoT Hub with Bluetooth devices. So the first thing, you go to this portal, you click Connect Your Device. You will see a list of some of the devices you can connect to the IoT Hub. I have chosen Use Another Device and Windows. And Microsoft is actually going to provide you with all the code you need. How nice is this? Just copy and paste it into your application, and you're done. You also need a connection string to your device. So that's the same connection string you can find in the Azure portal, but you need to add a device ID. But the Device Explorer actually gives you the correct connection strings. You can just copy it from there. So let's see. Bluetooth Internet of Things Robot. That's a really boring name. It should be called Bluetooth Robot, right? Of course. So there we go. Much better. Right. We're about to demo something. Now, actors know that they should never work with children or animals. As a speaker, you know that you should never work with Bluetooth. That can be disturbed by 1,000 people in the same area, venue. We also know that we should never rely on internet. So that's exactly what I've done. I'm relying on internet and Bluetooth. So let's just hope this works. There we go. So this robot actually has a bug in it. So I have to pair it every time I use it. This is made for parallel communication, but it will work, hopefully. I'm actually talking to Huawei, trying to solve this. So here I went into the Bluetooth settings and I paired the device. So let's go into messages. So I'm going to show you the code in a while. So let's do a explosive demo, C4. Sorry, I need to start the app as well. There we go. Let's try that again. So now I'm actually controlling my robot through the Device Explorer into IoT Hub, then back to my application, and then over to the robot. So let's try something else. See, I actually have a list of things it can do, so let's try a 7. Oh. So all the commands that is available through the infrared controller is also available through Bluetooth. So let's take a look at the code. Yeah. So what I've done here is that I create a device client. I create it from my connection string. So this is the connection string to my device. Then I have a RoboSapien class. This is the class that talks to the RoboSapien, and we will look at that in just a second. And then I say RoboSapien connect. This is going to try to find the device and connect to it. And then I also have a send event. So the send event is going to send RoboSapien connected message to my IoT Hub. And if you look at the Device Explorer, let's see, if I monitor it and I start it, so if I start the app, it will connect to the RoboSapien, and I will get the message RoboSapien connected if I monitor the hub. And then I have receive commands. So this is going to check, do I have any messages on my hub? If I have a message, I will convert it. I will get bytes. I will convert it to a message. And then I will call the send command on my RoboSapien and send in the message. So in this case, I'm going to get the bytes for C4, for example. Then I'm going to convert it to text and send it in to my RoboSapien. So let's take a look at the RoboSapien class. So here I'm actually not using my helper methods, just to show how easy it is. So first thing, I get the service GUID, get the characteristics GUID. Then I connect. I try to find the device selector. So I try to get all the devices that implement this service. And 1V is actually one of the examples that reuse their service GUID. So I have another robot that works completely differently, has different characteristics, but the same service ID. I actually think that it has the same characteristics ID as well. So I get the enumerator, and I get the device. Here I check, does it contain RoboSapien? Because the other robot is called MIP. I get the service, and I get the characteristic. Then we have the send command. So here, just take the characteristic and write the data straight to the characteristic. So I also have a method here that converts my C4 string hex to a byte array. So that's all it takes. So I can send commands up to the IoT Hub. Then it will return to my application, or actually every application that listens to that particular device. And then it would just send the bytes out to the robot. Sorry, that's not right. So here are some resources. Microsoft actually has a lot of great samples on their GitHub account. We have the Azure, the Device Explorer, and then we have the URL to my MIP WinRT SDK. Do we have any questions? Oh, I'm soon done. Thank you. Do we have any questions? No questions. So then let me round up just to say that, as I mentioned before, there are 3 billion devices out there that were manufactured last year alone. It is so much fun to do this. And if you have any questions about this presentation or Windows development in general, or if you're ever in Sweden, please come by Coding After Work. So I'm a kind of ahead of schedule, so I'm going to let you go. So please contact me if you want to. Thank you.